Our objective today is adding and subtracting scientific notation. Before we start, we're going to review the three components of writing a number in scientific notation. So remember, you only can have one number can be left of the decimal point. So that number in front of the decimal has to be greater than or equal to 1, but cannot be, it has to be less than 10. So anywhere between 1 and 9. You also must have the multiplication sign, and it must be to the power of 10. So for example, 5 2/10 times 10 to the third is written in scientific notation. We have one number in front of the decimal, and then that number is between 1 and 10. And we have a multiplication symbol and the power of 10. BIC number 1. When you are moving the decimal to the left, our base 10 power is going to get bigger. So you're going to add however many times you move to that exponent. So that exponent is going to get bigger. If you move the decimal to the right, then our base 10 power is going to get smaller. So however many times you move that decimal to the right, you'll subtract that number from your existing exponent. So steps to adding and subtracting scientific notation. So we're going to do these steps using the example 1 3400 times 10 to the 14th plus 1 300 times 10 to the 12th. And so our first step is when we're looking at a problem, you need to see if the exponents are the same. Your exponents must be the same. So if we look at our problem, we should notice that our exponents are not the same right now. So step 2 says if the exponents are different, then change to the largest exponent. So our largest exponent is 14. So we need to change this entire number here so that the exponent changes from a 12 to a 14. Well, if you remember from the BIC that if we move the decimal to the left, then our base 10, that exponent is going to get bigger. So we started with 1.3 times 10 to the 12. I need to increase my exponent by 2. So I'm going to move my decimal place 2 to the left. And so now this number is 0.013 times 10 to the 14th. So now our exponents match and we can continue to add. So once you have the same exponents, step 3 says add or subtract the numbers and keep the base 10 and the common exponent. So to make it easier, I always add vertically so that I can make sure that all my decimals are lined up correctly. So we have 1 3400, and I add in a 0 here because our other number had 3 decimal places so that I could keep it lined up. Times 10 to the 14th plus 13 thousandths times 10 to the 14th. And I went ahead and added a 0 as a placeholder to help line things up. And so now, when you add, you keep the base 10 the same. So we just rewrite the time 10 to the 14th, and then we add straight down. So 0 plus 3 is 3, 1 plus 4 is 5, 0 plus 3 is 3, and 1 plus 0 is 1. So my answer would be 1 353 thousandths times 10 to the 14th. Our last step is to adjust the decimal and exponent so that the answer is in scientific notation. In this problem, we are in correct scientific notation. We only have one number in front of the decimal place. But if you had more than one, or not any at all, you would need to move your decimal to the left or to the right to make that happen. So let's look at some examples. This is adding and subtracting when we had the same, not same base, but same exponent. So when we're doing this, we look, our exponent, the 4 and 4 here, so they're the same, so we can skip step 2 of making them the same. And so now all we have to do is add. So make sure that you line them up so that your place values are lined up together. So I added an extra 0 for that thousandths place. You keep the same base 10, so we have times 10 to the 4th. And so now 0 plus 2 is 2, 6 plus 2 is 8, 6 plus 1 is 7. Rewrite my decimal place, and 5 plus 2 is 7. So this is in scientific notation, so we don't have to change anything. And our answer is 7 782 thousandths times 10 to the 4th. So let's look at another addition problem. So we first look at our exponents. They're both 2's, so our exponents are the same, so we're good to go there. And so now I'm just going to add. So we have 9 and 89 hundredths times 10 to the second, plus 6 and 25 hundredths times 10 to the second. When we add, we keep the same times 10, base 10, and so now we add. 9 and 5 gives me 14, carry the 1. 8 and 2 is 10, plus 1 more gives me 11, carry the 1. 9 plus 1 is 10, plus 6 more is 16. Well, if you'll notice, this is not in scientific notation because we have 2 numbers in front of the decimal place. And so what we need to do is we need to move this decimal 1 to the left so we only have 1 number in front of my decimal. So now I have 1.614 times 10, but remember from your VIC, since we moved the decimal 1 to the left, our exponent's going to get bigger. I need to add 1, so now this is times 10 to the 3rd power. Now let's look at some subtraction. So we have 7 and 5 hundredths times 10 to the 5th minus 1 and 2 tenths times 10 to the 5th. Our exponents are the same, so now all we need to do is subtract. So we line them up, and I added a 0 place value so they could be lined up. I rewrite the times 10 to the 5th, and then I subtract. So 5 minus 0 gives me 5. Well, 0 minus 2, I couldn't do that, so I borrowed. So 10 minus 2 gives me 8. This became a 6. 6 minus 1 gives me 5. This is in correct scientific notation, so my answer is 5 times 8, 85 hundredths times 10 to the 5th. So if we look at our next example, we have 8 and 2 tenths times 10 to the 3rd minus 7 and 52 hundredths times 10 to the 3rd. Our exponents are the same, so all we have to do is subtract. So we have 8 and 2 tenths. I'm going to add a 0 so that we have the same number of place values, times 10 to the 3rd minus 7 and 52 hundredths times 10 to the 3rd. We rewrite the times 10 to the 3rd. Well, I can't subtract this, so I had to borrow 1. 10, we get an 8. Can't borrow here, we get 7. And so I get an 11, and I get 6, and then 7. Well, this is not in scientific notation. We don't have, this is a 0. It has to be greater than or equal to 1. So we need to move the decimal 1 to the right. When you move the decimal to the right, you lose one of your exponents, so our answer is going to be 6.8 times 10 to the 2nd power. Now, it would be very easy if that's all we had to do, but sometimes, like in our steps, we're going to have where the exponents are not the same. So what do you need to do when they aren't the same? So here we look at number 1. We have 7 times 10, or 52 hundredths times 10 to the 5th, plus 2 and 872 thousandths times 10 to the 6th. If you notice, our exponents are not the same. So we need to change one of our scientific notations to match the one with the larger exponent. So we need to change this first one. We need to add an exponent to get to match the 6. Well, increasing those exponents, we need to move to the left 1. So we're going to move the decimal 1 to the left. So now we have 0.752, and it turns from the 5 to the 6. Now they match, so now we can add. We rewrite the times 10 to the 6th. 2 plus 2 is 4. 5 plus 7 is 12. Carry the 1. 8 plus 7 is 15. Plus 1 is 6. 16. Carry the 1. 2 plus 1 is 3. So our answer is 3 and 624 thousandths times 10 to the 6th. So let's look at number 2. If you notice, we have 2 exponents that are not the same. The 2 is larger, so we need to change this exponent by moving the decimal. Well, we need to move, if we're at -1, if you think of a number line, to get to 2, you have to move from -1 to 0, and then to 1, to then to 2. So you're going to be moving the decimal 3 places, and we want to increase the number, so we're going to move them to the left. So when we move it 1, 2, 3 places, we have 0, 0, 3, 1 times 10 to the second power. So now we can take this and subtract it. Oh, no, that should be an addition sign. Sorry. We're going to add it. So we have 4.072 times 10 to the second plus 0.0031, and so I'm going to add a 0 there, times 10 to the second. These bases are the same, so we rewrite the times 10 to the second. 1, 2 plus 3 is 5, 7, 0, and 4. This isn't scientific notation, so we leave it like that. You're going to do the exact same thing when you're doing subtraction. So we look, we have negative 5 and negative 7. So if you notice here, this is the first time we've had two negative exponents. So our negative 5 is our larger exponent. It's closer to 0. So we need to change this negative 7. Okay? So we want to make it larger. So we're going to move the decimal 2 places because negative 7 plus 2 will give me that negative 5. So now I have 2.974 times 10 to the negative 5th. And since we moved the decimal twice, we get 0.0572 times 10 to the negative 5th. Rewrite your times 10 to the negative 5th and then subtract. Well, 0 minus 2 we can't do, so we had to borrow and carry. So 10 minus 2 is 8. 4 minus 7 I had to borrow again. 3 minus 7 I had to borrow again, so I have 13 minus 7, which gives me 6. 6 minus 5 is 1, 9 minus 0, and then 2. So we have 2.9168 times 10 to the negative 5th. This is incorrect scientific notation, so that's all we need to do. So let's look at the last problem. We look here. We do not have the same exponents. We have a 2 and a 1. So this needs to change to become a 2. Well, the difference in the 1 and the 2 is just 1. So we need to move the decimal place 1 spot. And we want to increase, so we're going to move that decimal once to the left. So now we have 4.86 times 10 to the second minus 0.102 times 10 to the second. And I'm going to add a 0 for a placeholder. We rewrite the times 10 to the second. Now we need to borrow. We have 8. 5 minus 0 is 5. 8 minus 1 is 7. 4 minus 0 is 4. So we have 4.758 times 10 to the second. We only have one number in front of the decimal, so it's incorrect scientific notation, and so you are done.